We'll demonstrate several vSecond use cases. While doing that, I'll repeat many commands, and since I wouldn't say I like typing things repeatedly, I'd like to save those commands as shell scripts. For this, I'll create a workshop folder because, well, this is a workshop. And inside the workshop folder, I'll create a hack folder to gather all my shell scripts. And I CD'd into this hack folder. As always, if you find value in what you learned today, please give us a star on GitHub at github.com/VMware/secrets-manager. Your support helps others discover this incredible technology. And back to our example. The first thing I'll do is to create this env.sh. env.sh will query my cluster for specific pod names and assign their names to environment variables. So, in my scripts, I can source this env.sh file, and I can use, for example, $Sentinel in my script, which will resolve into the name of my Sentinel pod. This is especially useful because even when the workloads are evicted and new workloads with different names are created, our scripts will still refer to them by their $workload, $safe, and $sentinel aliases. So, we won't have to alter our scripts. If it is unclear, you'll see what I mean once I create more scripts. Please bear with me. So when I execute source env.sh and echo $safe, I get this long string that is the pod's name for vSecond safe. So, for example, I can do kubectl logs $safe -nvsecond system to view its logs. Next, I want to create an inspector workload. Our workload will have a binary named env, so when I kubectl exec -env in that workload, that binary will list the secrets registered to that workload. Luckily, I already have a deployment manifest from a previous workshop, so I'll copy it and maybe slightly modify it. Then I'll paste it into workloads/inspector/deployment YAML. Let me remove the comments to give some extra screen space, and let's check this spec part. vSecond SDK uses these environment variables, and this SPIFFE endpoint socket is an environment variable that the SPIFFE workload API recognizes. The SPIFFE CSI driver manages the Spire agent socket here, enabling the workloads to talk to the SPIFFE workload API securely. In addition, our example workload will have the name vSecond Inspector, and it will use a service account named vSecond Inspector. It has these volume mounts to talk to the SPIFFE workload API, and if we check the source code, this SDK example container image has an env binary that we need. When I check its source code, I see that the binary prints the value of the secret when it is executed. That's all we need, so I can use it in my deployment. I'll replace the example multiple secrets here with example using SDK to use the image containing that env binary that we saw a moment ago. But what does this env binary do? It executes sentry.fetch to fetch the secret associated with this workload. Sentry.fetch is a vSecond SDK method, and since we have the source code, we can command or control-click it to see what it does. As seen in the code, sentry.fetch is a method that abstracts a lot of communication hassle with SPIFFE workload API to establish an MTLS connection with vSecond safe to fetch the secret bound to this workload. And while doing that, we have several validations. First, the code ensures that the request originated from a workload that vSecond recognizes. Also, we ensure that the response to our query is from vSecond safe. In other words, we check whether we can trust the responder's identity. We make a REST request to vSecond safe's /workload/v1/secrets internal API, and eventually display the response we receive from that API endpoint, showing the secret assigned to our workload, if any. And on the other end, at vSecond safe, we have a handler that does similar checks and validates its own identity, that is, making sure that the code is running in a workload identified as vSecond safe and not some imposter. This is followed by validating the workload's identity, ensuring that it is a workload that vSecumSafe knows and understands. And if it's an invalid workload, it returns an error. Otherwise, we get the workload ID from the workload's SPIFFE ID. Then we read the secret that is linked to this workload ID and dispatch the secret in our response if we find any. Having done a quick code review to see what's happening behind the scenes, let's go back to our deployment YAML and save it. Next, I'll need a service account to be used for my deployment. Again, I'll copy it from the former workshop and paste it into my terminal as serviceaccount.yaml. That's done too. Let's list what we have in the folder so far. Okay, we can deploy these for starters. kubectl apply-f. Then, let's do a kubectl get po. And after a few moments, our inspector workload is healthy and waiting for us to interact with it. Let me source the env.sh and then check if I have the inspector variable populated. Echo $inspector, and I have a value. So let's execute the env binary that will supposedly dump the secrets bound to this workload. kubectl exec $inspector --env, but I don't get any response. It feels like the connection is pending, and it actually is pending. Why? Because if you remember, vSecumSafe validates the SPIFFE ID of the requesting party to establish a connection. Likely, we don't have a cluster SPIFFE ID for this inspector workload since we just created it. Since the workload cannot identify itself, it cannot establish a connection and fetch secrets. Let's validate our assumption by executing kubectl get cluster SPIFFE ID. And yes, we don't have an ID for our inspector workload. Luckily, we created that ID in a former workshop. And here, I can use it as a starting point. Let us create an IDs folder first. Then create an inspector.yaml here. And here's the cluster SPIFFE ID that I will copy from this vSecum workshop/IDs folder. I will copy this and paste it here. Let's check it quickly. For this ID to be assigned to a workload, our pod should have a label vSecum inspector as a name. It should be in the default namespace, and it should have a vSecum inspector service account. This is enough evidence to validate the identity of our workload. I'll save this and then do a kubectl apply-f. And now when I do a kubectl get cluster SPIFFE ID, I can see inspector here. And when I run kubectl describe cluster SPIFFE ID vSecum inspector, I see that it has one matching pod, which means that now, when I run the binary, it can communicate with the workload API to fetch its X509 certificate to establish a connection to vSecumSafe. And when we run env with kubectl exec, we can now establish a connection and get a no-secret response, because there is no secret assigned to this workload, so it makes sense for it not to find any secret. In the next video, we'll continue playing with this workload and assign it secrets. Until then, keep your secrets secret.